Just waiting for the live stream to come up. Okay. Actually, why does this say there's no video? Hmm. Well, there's no video of me, so I guess I don't know why that is. Just a little slash to it. All right, well, whatever. Okay, you can stop. Um, just give me a moment here. There we go. All right. All right, 6 o'clock. We're live streaming. We are talking about I think we're week 11, but that's what this says. Okay. Let's see. Just an announcement that today is the 6th, and so what to do on the 6th? Let's pull this thing here. What to do on the 6th is mod 10. The sign regression is due today, so we're gonna have to make sure we break up in groups and finish that because I don't even think that it's in here, is it? Yeah, so the sign regression isn't in here. Anyway, the sign regression is going to be pretty much what we've been doing all along with the other regressions. We're going to sign regression. Okay, except this one's a little different because this sign regression, usually we do evaluate and solve, and this one's just going to be an evaluate, no solve. No solve. Okay. And so it should be a little easier. The hard part about this particular regression is, let me go back out to here. Okay, thank you. Well, the hard part about this regression is, I think we discussed it last time, was that we're talking about trig functions now. And so, oops, not the video, not the video. Sample. So you'll see we only have one sign regression thing, even though we're going to make 2 classes out of it, I believe. So if you look at our data, there's our data. We're not doing an evaluate, so you can turn that line off. So you can see these dots kind of make a curvy thing. And what you can do is you can say, okay, I want to make a regression that's set up like the sine function we saw before. So if you remember a sine function, y equals the sine of x. Let me turn that on. It looks like this. Oh, hey, that's not y equals sine of x. No way. That's y equals sine of x. Those little dots down there. They only, the sine function only goes up and down by a little bit. It only goes up and down by 1. So if you have a number that, if your graph's going all the way up to, what did we say, 1,000? So we put a 1,000 in front, and that will stretch the function by 1,000. That's 100. That's 1,000. And then we can raise or lower it. Okay, I don't want it to be 1,000. Let's make it 500, but raise it up by 500. So we'll do plus 500. Okay, that raises up. So that's about where we want to be, except you can see that it goes up and down. The period is much shorter. We want a longer period. So if you remember to make a longer period, we had to put a number in front. So we put a number 2 in front. Oops, that's 2. See, 3 makes it busier. So we wanted to make it longer so we could try like 1/2 or 1/3 or 1/5. Or I could make this 2 pi divided by some number like 50 or 40, or let's try 38. Okay, so now this function looks a lot like that one. Oops, I have the plus 500 in the wrong spot. Okay, now they're very similar. Okay. And then I can I want to move it to the left by 5. But if I do -5, you'll see it won't move to the left by 5. Well, it's close enough. Maybe 6. Nope. Anyway, so we can get a sign regression by doing this. So instead of me sitting here and fussing with it, I just told Desmos, I said, Desmos, find the best number in front. So the best number in front is 484. I said, find the best period, 2 pi over b. 2 pi over b would be equal to the period. So we put 2 pi over whatever that number is. A is, in this case, little a is the period. So A is 38 because I set it to be 38. C is 1.51. Really, 1.51? That doesn't seem like it would give the same graph at all. 2 pi over 38. Let's change this 44. And then D is plus 529. So anyway, I feel like it's off by a whole cycle. No. I think 38 is not the period. In fact, if I look at this graph, let me just zoom out for a second. I think there's something wrong with this formula. If I click on this, it's the 0.1, 1000. If I follow, I don't know why the graphs are the same color. That's 1 and 1000, right? 1 and 1013. If I go over here, this is 30. Yeah, it's the period is 38. So that number A is 38 is the period. Huh. Oh, I see, because I wrote minus 151. It should be plus 151. I'm moving it the wrong direction. There we go. All right, so anyway, that's just how all along we've been asking, and when we ask Desmos to do a regression, all these other ones, exponential regression or something, we say find the best values for P0, K, whatever. But in this case, we're saying find the best values for the period, the amplitude, the phase shift sort of, and then how much it's raised and lowered by. Okay, and that's what it does. Now I can change because I have the 38, I set 38 as the period, but I could adjust the period. And you see, if I make it bigger or longer, then Desmos is just going to find the best function with that period. So with the period of 60, this function right here, if you look at the top, it's minus 6 point whatever at the top. Here, one period later would be up here, it would be 53.6, which would be exactly 60 later than that. Okay. And the next one after that will be 100. If I do the next one, so let me just look at this one's 53. 60 plus 53 is 113. So this one right here should be at 113. Okay, I zoom out. So you can see the periods at 60. That's about how long it takes for this thing to repeat itself. And that's what a period is. Okay, so all you have to do is decide on a period and then And then we're not doing any solves, so you can just plug in any number you want. 2, 3, 4, 5. And so the producer just has to do any number they want. Even 0 would be fine. Even negative numbers. But so when I'm talking about a price of $2, I'm going to expect to sell 993 items. If I do $3, it's 941. If I charge $4, it's 864. Charge $5, it's 827. And this sign regression is good until we get to about 20 bucks. No, 20 bucks is okay. $22. So $20 is okay. $21 is okay. But $22, now I'm selling a negative number. So this graph dips below the x-axis right here. So that's a 0, and there's max and mins if you want to do them. But honestly, the max and min, because of the min is here, it's after the 0. We wouldn't want to talk about either of them. We wouldn't want to go to the minimum of 23, charging 23. After that, it makes even less sense. It means if I keep raising the price, the sales are going to go back up again. So this graph is only good in this little region here. Okay. Now, so what does the writer do? The writer does the same thing with it just says evaluated, boom. Okay. When we do get to the solve, we just turn it on and we just find it. So there's the solve. If you wanted to get that out of the way too, you certainly could. You could put in, oops, what was that? Oh yeah, I noticed that you can do this. You can lift the point out. So you can do it that way. That's a new feature of Desmos. How fun for us. Put that there. And so that means at the price of 10 point whatever, I would sell 500 items. Okay, so the writers can do the evaluates and they can do the solves and they can write it out. The solve is a little different. That's why I want you to do it later, because when you solve it, you need to know what the period is. If that's one solution, then 60 later is going to be another solution. Okay, so and then every 60 after that. So we write plus the period times n. In this case, it's still set to be 38. But yeah, there's one solution, but there's another solution over here, which is 37, and you add 60 to 37 and you get that solution. Oh, wait, 60 and 37 gives you 97. Okay. All right. The writer, the only thing different about the speaker is they're just gonna, according to the sign you're getting, you have to say what the period is. Since you're allowed to adjust the period, you have to say what it is. According to a sign regression with the period of 38 or 60, if we want to sell 50 items. Okay. You can do your evaluates and solves, but you just have to add what the period is that you guys decide on when you do this. Okay. Any questions on that? We're going to do that. I promised you we would do it at the beginning of class, but since I'm not totally sure everybody's here, maybe we should, why don't I go over the quiz and then we'll break up into groups and we'll finish this. Okay, anyone have any objections to that? Anybody? Yeah, we can do it now if you want. There's 16 people here. That's a lot of people. I hope nobody showed up to the classroom. Uh, are y'all paying attention? Are you awake? Somebody want to say something? I think, you know what? I think we'll do this right now. Let's get you warmed up and get this started, because I want to get this done before I move on to the next material. Okay, so since you're all here, let's do breakout rooms. I'm going to create breakout. Okay, breakout rooms. Do you remember which great breakout room you were in? Hello?
Yeah.
Okay. So I have 4 breakout rooms. Does anyone need to know what breakout room you were in? I think I wrote that here, but I'm not sure. Oh yeah, here we go. Uh, Is the breakout room showing up? Hello? It
No, it's
says
not.
they're open. Momin went in. Momin's in room 3. Okay. Um, AJ, what room are you in? AJ.
Three, I'm pretty sure.
Yep, you're in 3. Go for it. Bloop, I'll move you in there. Alexis, are you also in room 3? I think so. David, I think is in room 1. He's a business group into room 1. David. Dennis R is in room 3. Jake O'Grady is in room 1. Justin is in room 2. There's a lot of people in room 2, Justin. Taylor Herrera. Room 4. Taylor, you're the only one left in your group. Are you there? It was you, Ezra, Alejandro, Jap, Michael T. Michael T was here last time. Wow, Michael C is here today. Taylor, what do you want to do? Maybe you should answer me. Hello. Hello.
You say my name?
I said, is this Taylor?
Yeah.
Taylor, your group, you're all by yourself. Do you want to
Uh,
join one of the other groups?
yeah. So I was in group 3 last time.
Okay,
'Cause,
so
yeah, I was the
go.
only one on group 4.
Yeah, Michael T was here last time, but he's not here today. So let's, I'll put you in room 3, or you can
Okay.
go to room 3. Okay,
All right. All right.
off you go. Oop. Let me take attendance now. Hello, Dennis. What's up? What's going on? You guys popping out of room 3?
Yeah, I just wanted to see if my graph is right.
Oh, you want me to come? Go back to room 3 and I'll come in.
Okay.
Okay, I'll be there.
Uh, I think you need to send me in there. Hold on.
Oh no, just
Yeah, I got it. I got it.
okay.
Do you want to break
I'll
out?
be here. Dennis, why aren't you back in your room? What happened? Dennis. Dennis. I'm gonna move you again. You're supposed to be in room 3. You just have to join. I can't move you. I've moved you as much as you can. You just have to join. Okay? Join, please. All right. I'm just gonna take a test attendance then. Justin is here. Joseph is here. Michael C is here. Sebastian is absent. Emiliano absent. Herrera here. Octavio is here. Tatiana is not here today. What's that about? Jake O'Grady. Jake O'Grady is here. Christopher is not here. David is here. Genesis here. Akash here. Dennis is here, but he's not responding. Jimmy Seeds absent. Alexis here. Momin here. AJ here. Absent. Michael T. Absent. 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 Alejandro's not here. How many does that make? 13? 5, 10, 11, 12, 13, 15. I have 15. Who did I? Sebastian is here. Okay, Sebas is under Sebas. Is present. Tatiana is here. So how many does that make? 15, 5, 10, 15. Good. Okay, attendance is done. That's 2. See how they're doing. All right, let's get back to sharing. Share screen. There we go. Mm. Mm, mm, mm. I don't know what's going on there. All righty. Here, here, this over here. Where's Alex? Alex, as long as it's gone. Mm, 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 Alex. Assignments. I'm going to be going over quiz 9. That is due today. Okay, there's one really bad one. And the rest are okay. So go over the really bad one. And it's 6:35, so time to break the breakout room. Break out the breakout rooms. All right, breakout rooms. Close all breakout rooms. And back they come. Okay. Dennis, are you still there? Hello, David? What is going on with this?
Yes, Professor.
Okay. Can you see the screen, David?
Yes, Professor.
Okay, because I'm going to resume here. Okay. The breakout rooms are most closed. Guys should all be back. All right, let's take a look at what you presented. The heck? Or what I see. Lessons. Discussion. Sign, evaluate. Okay, so these are the 3 groups. AJ's group has 3 comments. So good. So this is a graph of the period of 40. Looks like a period of 40. It goes up there and 40, and then he's got a table with some values. And this is AJ. Can you fix this? At some point, your X coordinates say weight and your Y coordinates say height. And I'm pretty sure it's the other way around.
Yeah, it keeps changing every time I go back into the document. Yeah.
Oh, because your original, yeah, your original, yeah, okay. All right, so this is perfectly good. So great. So what did Alexis say? Uh-oh. So Alexis is doing an evaluate at 95 inches. Really? Why did you pick that, Alexis? Who do you know that's 95 inches tall? A. And B, do you see this graph? It goes up and then it comes down again. That 95 is way over here. That doesn't make any sense that someone so tall weighs so little. Why don't you pick one of the other ones? Like 65 works perfectly fine. 65-inch person is kind of skinny at 147 pounds. But hey, Akash wrote, Akash is giving me the evaluate like it's a solve. Mm, mm, but it's still an evaluate because you're not solving for 140 exactly. You're plugging in 60 and getting 140. Okay, but since this is an evaluate, it's okay. Justin's doing 75. Okay, somebody has got to say this in words. So somebody in the group, Alexis, why don't you do it because so change your thing to say according to the sine regression with a period of 40, a person who is 60 inches tall or some person who's 75 inches tall should weigh 220 pounds. Can you do that?
Want me to type it out or?
Type it, take out what you put in there, edit what you put in and put the writer in because you need a writer.
Oh.
Or not a writer, speaker. Everyone else is. I mean, if you want to do a video, that would be great, but that would be a lot to ask. Okay. All right, let's go back to, whoa. What's that? Okay, so let's go back to the sine regression. And nope, I'm looking at the next group, Moment's group. Okay, Moment, nobody replied to you. So they should reply. That's due tonight. I mean, I can give you more time. I probably won't. I probably will give you more time, but you guys should reply. All right. It looks like David is doing also another evaluate written as a solve. And Tatiana, okay, Tatiana, you have to put the 2021 in parentheses to be S of 2021 equals 9.3 million. I like Tatiana's the best. David is, it's okay. It's okay. Those are both evaluates. It would be nice if somebody said, according to the sine regression with a period of, what is your period? 38. In the year 2026, there will be 10.75 million people in New Jersey. Okay. All right. Maybe somebody can add that since there's two people missing. Okay. All right. Any questions on that? Questions? Make sure you post something because I'm grading those things. Okay. Let's get back to Alex then. All right. So that's our discussion. We're done with our discussions. Now let's take a look at last week's quiz. Because this is also due tonight. Now I see a blaring number 5 needs work. So let's take a look at problem 5. And I think what I'm going to do is create a I'm going to go to a Desmos thing. Here's Desmos. And I'm going to put it on this side. Oh, put Alex on this side. Okay, so I could fuss with this. Just like I did before, I could say, oh, I want it to be a sine function. And I could say, okay, I want the amplitude. I want this to go up and down by 4. So I could put a 4 in there and it'll go up and down by 4. And I want the period to be, let's see, 2 pi over b. What's the period here? The period, it looks like it's 1. Goes from the bottom to the bottom and it takes 1. So the period is just 1. Uh-oh. Am I in the right thing? No, I'm in the right thing. Okay. Maybe it's just because my graph is zoomed differently. All right, let me just change my wrench here. So I make my y values go from -5 to y values will go from -5 to 5. Okay. And my x values will go from negative, looks like 1/4, -0.25, all the way to 5/4, which is 1. Okay. Does this graph look like that? I suppose it does. Except my graph starts at 0, and this graph starts in the middle and goes up here in that weird spot. Okay, so I could, to get it to move over, minus, let me see. I know I'm going to have to move it to the right. It's going to have to be minus some number, but 1/4 probably won't do it. Quarter might be it. Anyway, I don't want to do it this. So I'm going to, before I do that, I mean, I can figure out what that is. That's going to be some C value. And I know that the 0 here is at 1/3 of 1/4, or 2/3 of 1/4, 2/3 of 1/4, 2/3 of 1/4. And that equals, so that's my 1/6 is where the phase, that's the phase shift. Plus 1/6, and that's the phase shift. And the phase shift, sorry. The phase shift is equal to, so 1/6 is the phase shift, is equal to minus C over B. Okay, B we know is 2 pi. 2 pi. And so now I know what C is. I can bring that 2 pi up there. So I say C equals minus 2 pi over 6. Okay. Oh, because that's minus a negative, so it's actually plus, sorry. That's better. Okay, so right there is that 1/6 the same as that. So this graph looks like that graph. Okay, so what did we say? That was pi over 3. Pi over 3. Okay, so that's the answer that I want to type in there. So if I type in, it says, write the equation as I described. So I think you have to do y equals 4 sine parentheses 2 pi x minus fraction pi over 3. I think that might be it. Let's check it. Oops. That's correct. All right, let me show you now another way to do this. That was fine. If you followed that, that's fine. But you could use exactly like what we just did. And here, let me do that. I'll leave those there for you. I'm going to do something else. I'm going to take a table and I'm going to put some data in it. Okay. Each one of those little slash marks is 1/12. So at minus 1/12, the y value is -4. Okay, you see how you see that blue dot there and how I took it off of that graph. Okay, that's fine. And now at at positive 2/12, so let me do 2/12. the value is going to be what? Anybody? Alexis, what do you think the value is going to be at 2/12? Looking at this graph. Anyone? No, Alexis, answer. Good. What's that value right there? 2/12. It's the Y value. See the arrow pointing? See my mouse pointer thing going on there? Maybe not. Maybe you don't see it. What's this right here? Oh, hold on.
Yeah, it's frozen.
What's frozen? Right there. What's the Y value right there? I'm not pointing. Why is it not a point?
2.
No, that's 2/12. You see, that's 1/4, so that's 3/12. This is 1/12, 2/12, 3/12, 4/12. So that right there is 2/12. But what is the Y value there that I'm going to put into my table? AJ, what's the Y value?
0.
Thank you, Akash. It's 0. Okay. The next one I'm going to look for. So I got the minimum. I got that 0. Now I'm going to go for the next one up. Actually, if I just at this point hit enter, it'll automatically go to 5/12. What's happening at 5/12? Where's my 5/12? So hold on. 1, 2, 3, 4, 5/12. Where's the function at 5/12? What's the Y value there?
4.
Is 4. Yep. And then the next one I'm going to get is this one right here, which is going to be what? What's the Y value there, Dennis?
0.
What's going to be 0?
Negative.
And then -4. Yes. Good. So I'm just going to put these in this way. So 4, 0, -4. Now, when I do that, do you see how look at the decimals, see how it put those blue dots exactly where I want to be now? Mind you, when you're doing this in decimals, you're not going to have that. I mean, you're not going to have the red thing. You're just going to see the dots appear. And if those dots appear the same as they do on that graph, then that's fine. Now, all you have to do is copy this over. You can literally copy it over from the worksheet. Where is that worksheet that we had? Well, anyway, I'm just going to write it down. This is a y1 tilde a sine b x plus c plus d. Oh, you have to put an x1 there. There we go. All right, see that now that created a purple line, and it tells you what the values are. A is 4, B is this number, C is that number, D, it looks like 0. Okay, that 10 to the -16th is 0. Okay, so what do I type into? How do I know what to type in? So A equals 4 is correct. So what is B? So here's how you figure out what B is. That's B. I just typed in B. If you want to know what B is, it's obviously got some pi in it. So divide it by pi, and you'll see that it's 2 pi's. Okay? So if you divide it by pi, it'll tell you how many pi's it is. So B is 2 pi. So B is the same as 2 pi. Okay? Because when I divide by pi, I get the number 2. Okay? Does everyone understand that? If you understand that, then you'll tell me what to do about C. What can I do to find out what C is? C is minus 1.04. What is that? What can I do to figure out what C is in terms of pi? What can I do? I just did it. So to say it out loud, somebody tell me out loud. Come on, Jake, what did I just do? Oh, somebody else is answering. No. Yes? Jake? Taylor, what did I just do to figure out what B was? I'm doing it again to figure out what C is. Come on. Let me do it again. I took the B that I knew is that's right there is B is 2.6.28. So I just typed in B and it says 6.28. So then divided it by pi to see that I get the number 2. So then I took that pi away and then I said, okay, if I take the number 2 and multiply it by pi, that should give me the same answer. And it does. So what am I going to do with C? That's the right C. C is minus 1.04. What am I going to do with it?
Divide by pi.
That's a chick divided by pi. All right, so what is that? What number is that? Okay, I don't know, it's a long decimal, but I can click on that little circle. How about minus 1/3? So now what can I do with minus 1/3? If I want to get the C back,
Multiply it.
yep, multiply it by pi. So you see how C is the same as minus 1/3 pi. Okay, so now you can put it into Alex. You put in 2 pi for B and you put in 1/3 pi minus 1/3 pi and you'll get the right answer. Let's try another one. Only hopefully it'll go a little faster. All right, I gotta clear away all this stuff. Where's my annotation thing? There it is. So I'm gonna do my annotations now. I want this point at the bottom. I want this point at the bottom. I want this point there. And now it doesn't say it, but I need the midline. These are, but the last one, the midline was right in the middle. So, but I see that this needs a midline that's halfway between 2 and -6. 2 and -6 would be somewhere around here. 1, 4 would be here. This is the midline. So I want that one right there. And I want that one right there because that's the midline ones. Okay, does everyone see that this is a sine regression. It's going to go up and down from the midline. The midline is halfway between the top and the bottom. Okay, so who's going to tell me what those points are? Anyone? Tell me the first one. The first one, the farthest one to the left is what? You know what? I'll do it this way. Just add another table here. Okay, what's the leftmost value? What's the x coordinate? Somebody else. Taylor. Taylor. What's the x most value here? What's the x value of this arrow? The first red arrow going up. What's the x coordinate?
It's -6.
That's the y coordinate. It's -6.
Oh,
Correct.
the x.
The x coordinate is minus what?
Pi over 2.
-3.
Pi over 2. That's it.
Oh, 5/2.
Do you see that? Go up. Just go straight up. You see it's labeled minus pi over 2. Okay, what's the next point? The next arrow that's going sideways. It's going from left to right. It's pointing at what? What's the x coordinate there? Anyone?
0.
Which
Zero.
arrow?
I should label them. That would be better. So this was the first one right here. This was number 1. The next one here is number 2. And the next one will be, this one will be 3. This one will be 4. And that one there will be 5. Do you see how I picked them? I picked them in the order I
Yeah.
picked them. Minimum, middle, maximum, back to middle, and then bottom again. Okay, so what did you say? What's 0 what? What's the y value here?
-2.
-2. Okay, now somebody besides Jake, tell me what the y value, the x coordinate is for number 3. for arrow 3?
Pi over 2.
It is pi over 2. Very good, Octavio. And what's the y value there?
2.
2. So now if I just hit enter here, it should give me didn't do it. All right, what's the next one? How about 4? Where is that? 4 is where? What's the x value?
Pi.
Pi. Very good. And the y value, Alexa?
-2.
-2. Very good. Okay. Somebody else want to grab the last one? Anyone? AJ, you haven't said anything in a few seconds. Because you're not here. How about Sebastian? Sebastian, what's the x and y values here? For line 5. Starts with 3. 3 what?
3 pi over 2
Right over 2. Thank you. And then the
Minus
y
6.
value
minus 6.
-6. Okay. So now that I have that, okay, I can just do what I did before. Y2 tilde a sine b x1 plus c plus d. Okay, let me turn off the purple one because I don't need that purple one. So now I have the red dots. Oops. I have the green graph. The green graph doesn't go through any of those red dots. What you talking about? Right? I put the red dots in. Let me just double check. Minus pi over 2, 0, pi over 2, pi, 3 pi over 2, -6, -2, 2, -2, -2, -6. They look good. Oh, I'm sorry. I can't reuse those letters, can I? Shoot, because A, B, C, and D mean those things right there. I'm sorry. I'm just gonna kill that one. Okay. Now, okay. Zero. Oh, x1. I'm sorry. That's x2. There we go. Much better. Okay. Does this graph look like that? Well, I see the red dots and I see this green graph goes right through them. So this is the answer. Oh, and look at this. There's no pi's in the answer. So I can just literally type it in. I can do y equals the a, which is 4, sine of b, which is 1, so I just do x, plus c, which is 0, plus d, which is -2. Okay, check that. And it's correct. Okay. If you put the points in and ask for the regression, it'll just tell you the regression. If your x values have pi's and stuff in them, your answers don't look like they don't. Okay. Do you want me to try another one of these? Are you feeling up that you might be able to do another one? Anyone? Yes? No?
We can do
Okay.
one more.
Good, because this question almost always shows up on the test. If it just, do you want one with pi's? This has pi's in it. Let's have one with pi's in the answer. This one will have pi's in the answer. So let me clear off all the stuff here. Ooh, this one's got a nice nasty one. Okay, so let's get some points. Do you need me to point them out? Does someone want to start with a point? What's the first point you see where you have a minimum or midline or a maximum? What do you got? What's the first point you see? I don't want to label it. So give me a point, any point. I'll take any point. Preferably a bottom point or top point though.
-2.
-2, 0, right? What's the next one, Alexis, while I got you? Where is it in the middle? 0, 1. Right? And when's it at the top?
2, 2.
2, and it goes all the way up to 2. Okay, and then the next one is 4, back in the middle at 1, and then 6, it's at the bottom. Okay, and that's what it looks like. It goes like that. If I adjust my window a bit, I can easily get it to look better. I'll need to go from -1 to, okay, so this kind of looks like that shape. So I'm just going to copy this thing here, copy and paste, but I'm going to change because since I have a third data set, I'll put a 3 there and I'll put a 3 there. Oop. Do you see how the green line goes through all the red dots? See that? So that's our answer. So now what's our answer going to be? So when I go to type it in, I'm going to say y equals A is 1 sine of, what is B? How do I find out what B is? Anyone? What do I do? B. Ugh, I used B already. So I gotta get rid of these.
0.7, Professor.
Yes, it's 0.7, but how do I find out what it is? Because I can't put that into Alex. It needs an exact answer. Like maybe it has a pi in it. So how do I figure that? What?
Divide by pi.
Divide by pi. And then I can click on the circle. So what is 0.25? That's 1/4 pi. So basically, what am I saying? B is what? The answer was 1/4, but what do I do? To get B, I do 1/4 what?
Multiplied by pi.
Pi.
Divide by pi.
See that? So now I see B and 1/4 pi are the same answer. So that's what I want to put in here. 1/4 pi. And then I put in X. Plus the C is 0. I can write plus 0, but I'm not going to. I'm just going to close it. 1/4 X, close parentheses. And then I have to do plus D, and in this case, D is 1, so just do +1. Okay, check that. Okay. Any questions on that? So I kind of think this is an easier way to go. Okay. I mean, you just have to identify the right points. Okay. This one, and you have to do it, and it's kind of hard to do without identifying the points. So if I was going to do this one, it would be, let me just very quickly do, half of 1/4 is 1/8. So it's 1/8. It looks like 3/8. It looks like 5/8. And then it looks like, oh, they're changing my 2 7/8 and 9/8. And at 1/8, the answer is -1. And then it goes to 0. Then it goes to 1. Then it goes to 0. Then it goes to -1. So once I get those points in there, okay, it just, I automatically have this, it tells me exactly what they are. A is 1, B is, so in this case, when I do B and I divide it by pi, I get the number 2. So here B is 2 pi. B is 2 pi. And then, oh, I don't know what C is, so let's just type C. C divided by pi, and I get -3/4. So let me just write -3/4 pi and show you that that's the same as C. And it is. So then when I go to Alex, I'll just type in y equals the 1 times the sine of b, which is 2 pi, 2 pi, oops, 2 pi, you have to do it this way, x. And then we have a, it's -3/4 minus fraction 3 pi over 4. Close fraction, and then it's that d is probably 0. Okay. All right. Does everyone get the idea for this now? I like using the regressions. We've been using them all along. So this is just a nice way to get them. And all you have to do is ask Alex to, you have to do is ask Desmos to, when you have answers that have pi's in them, divided by pi. Okay. Any questions on that? All right, let's see what we got. I don't have any of these to do. One thing I have to say about the domains and ranges of trig functions, this is not my favorite question. You just have to do this once. You have to look at these graphs and use your knowledge of domains and ranges. So the first one, if you're doing y equals secant x, oop, you can see that it's missing there's vertical asymptotes all over the place. So where are those vertical asymptotes? Well, if you type in x equals pi, it's not there. How about pi over 2? It's definitely there. So that's one of them. So let's try another one. X equals 3 pi over 2. That's another one. So it looks like the domain is everything except the odd multiples of pi over 2. So if you look, it says the set of all numbers except the odd integers of the multiples of pi over 2. Okay, now what's the range? The range, get rid of these x's. The range, remember if I do, so y equals 1. Y equals 1 is in the range. Y equals 2 is in the range. Y equals 3 is in the range. How about y equals 1/2? Not in the range. Okay, y equals -1/2. Not in the range. In other words, those are not, that red line is not hitting the function anywhere. But y equals -1, that's in the range. So it's all the things bigger than 1 and all the things less than -1. So it's, I see something. Here's the set of numbers from -1 to 1. No, I don't want that. Oh, it was sitting on it. All the real numbers less than or equal to -1 and greater than or equal to 1. Okay, so that's sort of what I expect you to do with these. There's only 6 trig functions, so there's only 6 possible problems. If I ask for another one, it'll just be cosecant, cotangent. There's just the 6 of them, and you get any 3 of them. So if you think this problem is going to show up, sometimes it does. It's not the most common problem. Domain and ranges. Okay, this one though I really like. Period, amplitude, and phase shift. Okay, if I give you an equation like that, you should be able to find the period and amplitude and phase shift by knowing, in this case, the amplitude. Okay, so the amplitude is, so if let me graph this graph, what the heck? Y equals -4 cosine of x minus pi over 3 plus 2. Okay, let me zoom in, and I see it's going up and down by 4. So I should make the y values go like minus 5 to 5. That'll look better. Okay. So there, that shows going up and down. Anyway, the amplitude here, it's going up and down by 4 because that's the number. The amplitude is going to be 4. And by the way, it's not -4. Negative will change the graph. If I change it, it goes that way. Okay, that negative flips the graph, but it doesn't change the amplitude. So when we talk about the amplitude, we don't talk simply about that number in front. We talk about the absolute value of that number. So the absolute value of that number is 4. Okay, what's the period? The period is 2 pi over whatever the b value is here. The b value here is the number in front of the x. It's just pi. So what is 2 pi over pi? So the period must be 2. So if you look at these, if you go from top to top, so this top is 1.33333, this must be 2 later, 3.33333. So that tells us another way of finding the period is just to click on the two tops and subtract them. Okay. What's the phase shift? To find the phase shift, you just take this, whatever's inside the parentheses, and set it equal to 0. That's the phase shift. Not exactly. I think that gives us the answer, but honestly, that's not the best answer. For cosine, you should be getting the top value. So the phase shift should be this guy right here, just minus, it looks like 2/3. But it's giving us this answer is 0.333. That's 1/3. Let's see what happens if I give it 1/3. Third is technically the wrong answer, but it's probably going to say it's correct. Yeah. So it just says, take this, set it equal to 0. Okay. And if you want that number, it's right there. It's 0.3333. Okay. You can solve this if you like to get, you could say, okay, so that equals pi over 3. You can divide both sides by pi. And there you have the answer 1/3. Or 0.33333. Okay. Should try another one. Let's try one where you guys tell me. Okay, here's a good one. Joseph, can you do me a favor and tell me what the amplitude of this is? It's going to ask you for the phase shift period and amplitude, but the amplitude is the easiest. What's the amplitude here, Joseph?
The amplitude?
Yes.
Why is it that? So x minus p?
No, that's the phase shift. That's how you find the phase shift, or the amplitude is the number in front of the sine or cosine. What's the number in front of the sine or cosine? What stretches the function?
The -4, cos.
It is, but what did I tell you about the minus? Don't use the minus, just say 4.
Which is 4?
Yep. The amplitude is how far up and down it goes, so it's a positive distance.
Okay.
The negative is going to reflect it, but okay. Tatiana, what's the period going to be? Do you want me to graph it?
Yeah.
Okay. So let's graph it. First, let me turn all these off. I'm going to graph it. Y equals -4 cosine of 2x minus pi plus 1. Okay, so what's the period? How can I find it?
I think I'm getting them mixed up. It's not the highest one. Is that the period?
It's not the highest one per se, but I always click on the highest one because it's easy. That's 0.5. I click on this one, and what's that?
Pi and 5.
So what's the period? How long did it take to go from peak to peak?
Just 5?
No, 5. 5
Pi?
stayed the same. It's pi.
Oh, okay.
Okay, and the way you get that is 2 pi divided by the number in front of the x. What's the number in front of the x here? The number in front of the x is the number 2. So that's why it's pi. Okay. 3.14. Anyway, that's the period, but I like clicking on the top better. That's a great way to find the period. The phase shift. Okay. The phase shift is hard, but I think we could just take this, what's inside here, copy it, and set it equal to 0. So where is that going to be? Oh, it tells you right there. What's the answer? Go on, Tatiana. What's the answer? What's the x coordinate?
Pi over 2.
Over 2. And that's the answer. Sure. Okay. So everyone understand that these are all, there's not going to be anything but sines and cosines here. Tangents and cotangent stuff have different formulas for period. But we don't have to worry about that. Oh, look at this one. That one's nasty. Nobody won't do that though. Okay. All right. So I like the period amplitude. I like the one that these three that I went over are all good ones. Sketching is easy. I don't know why people miss those questions, but for the sketching, all you have to do is when you're in Desmos, you just have to click on the high point, the low point, high point, low point, and you have to find the midline. Now, if you want the midline, you can't see it. You see this function goes up as high as 5 and goes down as low as -3. So what's exactly between 5 and -3? 5 plus -3 divided by 2 is 1. So if I just graph y equals 1, so watch where y equals 1 is. So that's going to tell me I need those points there. And Alex is great. Or not Alex, Desmos is nice because it gives you all of the things in terms of pi. So it's 0, 5, pi over 4, comma 1, pi over 2, comma -3, 3 pi over 4, comma 1, pi over 5. You just put those into Alex and you tell it to graph it and it'll be fine. To say put those 5 points in and Alex is fine for any of these, for any of those sketches. All right, let's move on because we have to start. I have to do quiz. Oh, what happened? I lost Alex. Oh, well. I'll go back in. So now let's take a look at the next quiz. What's going on in the next quiz? Oh, I do not want that. What happened here? So we're looking at quiz 10 now. This is due next week. It's due on the 13th. Let's take a look at it. Okay, content. There are 6 questions. Okay, there's a word problem involving sine or cosine. Now, for this one, okay, for this guy right here, you're going to read it and you're going to put those points into Desmos. Where's my Desmos graph? I'm going to grab my Desmos graph. Remember when I did the Desmos thing and I had data points and I wanted to have the data points? Let's just do it this way. Hold on. U to the right, U to the left. And it says a buoy is flowing, is bobbing with simple harmonic motion. So what you're going to do is you're going to create a table. Okay, and you're going to it's bobbing with an amplitude of 9 and a period of 0.5 seconds. Okay, so it's going to start at 0 and it's going to move up. Okay, so it's going to start at 0. So when x is 0, the y value is going to be 0. And then it's going to move up. Okay, and it's going to move up until it gets to 9. and then it's going to move back down to 0, and then it's going to go down to -9, and then it's going to 0. That's what the buoy is doing. It's going up and down. And it says the period, it's going to take 0.5, right? That was the period. 0.5 seconds. Okay. So that means it's going to end at 0.5. Okay. So I have a picture of where it starts at 0, 0, and it ends at 0.50. Okay. At exactly halfway. So at exactly 1/2 of 0.5. Okay. It's going to be back in the middle again. So it's going to go up, then it's going to go to back to the middle, and it's going to go down. It's going to go back there. So where is exactly halfway between half? Oh, yeah, I want another half. So at the quarter point, it's not, it's going to be all the way up at 9. Okay. Quarter of, why isn't it graphing? Oh, because it's up at 9. Hold on. Y values have to go between -10 and 10. Okay, so see, it went all the way up there. Then it comes back to 0. And then what's exactly halfway? But you said it's 1/4, 1/2. What's the next one going to be? What's after 1/4, then 1/2, then what? By the way, if I create a table and I do this the right way, I think if I do it the right way, Desmos will figure it out for me. So it's 0 times 1/4, or 0 times 0.5. Then it's 1/4 times 0.5. And the next one is 1/2 times 0.5, and then it's the next one, and then the next one. So Desmos just knows to automatically do them. So this one right here is 0.375, 0.375, or it's in other words, it's 3/4 of 0.5. Okay. Anyway, that's one way to trick Desmos. It's telling you the answer. So, oops. Here we go. All right, so now that I have the 5 data points, I can do what I did before. I can do y equals, or not y equals, y, in this case it's y4, tilde, obviously a sine b x4 plus c plus d. Okay, I must have used the lay in little b before, somewhere up here. Oh, I didn't use the lay in little b before. Why is it not going through A, B, little c? Did I use little c before? No, those are capital C's. What is little c equal to here? I must have used it before. Let me just mark this with the 1s. There we go. Now let's do that better. I don't know. So here's my data points. Let me just graph them. 0, 0. I can't see them because they're red lines over. There's the black dots. Those are my data points. When asked to do a regression, it gives me this red line right over them. So that must be the answer. Ooh, but now look at that B. So when I go to type it in, I'm going to do 9 sine of, B is 12.5 something something. Or at least I know what C is. So there's going to be an X there. Then there's going to be a D is 0. So how do I know what B is? The little b. It's that. How do I find out what that is? Anybody? Genesis. What do I do?
Divide by pi.
Divide by pi. So that's 4. So what is that number? What is B equal to then? B is equal to 4 what?
4 times pi.
4 times pi. Okay, so that's what I type in there. So I do 4 pi and then x. Why am I getting an x? Oh, because it wants it to be t. Sorry. This is a function t. So let's check and see if that's right. That's correct. Okay, so this one's not, it's just, all it is a word problem, and you have to understand the buoys going up and down, and you have to figure out from the period, they tell you the period is 0.5. The other points you're missing are going to be, the midpoint is half of a period and a quarter of a period, and then 3/4 of a period. It's always going to be that way. So if I have a different one, here the period is 2 seconds. So I have 0 times 2, I have 1/4 of 2, I have 1/2 of 2, I have 3/4 of 2, and then I have just 2. Okay, and then it's going, the amplitude is 13, but it's initially moves up. Oh, it's starting at 0, it's negative 13. So at 0, back. At 0, it's negative 13. And then it's going up, and it's always going to go up to half to 0. Then it's going to go all the way up to 13. Then it's going to go back to 0. Let's go down to negative 13. That's what that's saying. Okay, and then you can get the answer from here. It will be D equals 13 sine of that B is pi. I recognize it. B, that's Bx. C1 is, that's pi over 2. So it's plus pi over 2. And then D is 0. So there's nothing to put in there. Okay. Uh-oh, my answer's incorrect. What did I do wrong? 13 sine pi x plus, oh, that's minus pi over 2. That's why. Minus pi over 2. Okay. Recheck it. Uh-oh, it's one last time. Is that not pi over 2? C1 divided by pi. No, that is pi, 1/2 of pi. Oh, where's my variable? T. There we go. Whew. I was worried there for a second. This worked good, except I was careless. All right. All right. The rest of these go pretty easy. All right. Well, now you know what? The rest of these aren't going to go so easy because it says find the exact value. The nice thing about Desmos is you can just type in what you see. The inverse sine of the square root of 3 divided by 2. Here's the problem with this. It wants an exact answer, but look, it says in terms of pi. So Genesis, since you're still up, how do I figure out what that is in terms of pi? What can I do? What have we been doing all along? That's some multiple of pi. So what do I do? What did I do before to figure out what B was and C1?
Divide by pi.
Divide by pi. And what do you think the answer is? It's 1/3. So what's the answer? 1/3 pi. Okay, so that's going to be the answer. All right, so this was nothing hard about this. You type in what you see, the inverse tangent of the square root of 3 minus the square root of 3, tan. inverse of minus the square root of 3. Okay, and divided by pi, and you get minus 1/3. So it's going to be minus 1/3. And then I took out a pi, so I have to put the pi back. Okay. All right. So if you know how to do that divide by pi thing, you're in pretty good shape for these problems. This you literally just type in. So for this one, you just type those numbers in, and it says rounded to the nearest hundredth. So you're just gonna, when you type it in, it'll say exactly, even when it says undefined decimal, so just say undefined. The only problem you'll do here is if you happen to switch to degrees and not in radians, these answers all in rand. Give your answer in radians. So you have to make sure you're calculating your. Now let me just do that one. Where was it? Do any one of these. The inverse tangent of 2.14. So the inverse tangent of 2.14. Okay. So the answer is, in radians, it's 1.13. But if my calculator were in degrees, I would get a different answer, 64.9. So I want 1.13. So let's just, the answer is 1.13. Okay. So just make sure you're in radians. All right. Another one of these. You can go ahead. You must stay. All right. Composition of interest. Okay. So this one right here. Okay. Find the exact value of this. Again, I'm just going into Desmos and I'm typing in exactly what I see. Sine of the inverse tangent of 24/7. And the answer is 0.96, but what's the exact answer? If I go like that, it says 24/25, so that must be the answer, 24/25. Okay, it's possible. Yeah, these will all be some fraction and they'll all be pretty easy. The other ones, the group 5 ones will be something a little different. So this is, let's try something else. Okay, the arc cosine of the sine of 7π/6. All right, so let's do that one. So this is the arc cosine means inverse cosine. Okay. Sine of 7π/6. Okay. Now, Genesis. Look at what it says after. It says, write your answer in radians in terms of pi. What do I do? Genesis, I know, knows what to do.
Divide by pi.
Divide by pi. And then do what? What's that? I get the little button there. Tell me. So the answer is 2/3 what?
2/3 pi.
Thank you. Okay. Easy, easy, right? Are those easy? The last one's not going to be so easy. Okay. The last one is the one that requires that you can't just plug it in. You have to understand what we're doing here. So all those other ones you're just plugging in. This one, I have to show you some work for. Okay. And here's the thing about this one. And I have to do it. Hate doing this with the annotate, but I'm going to do it. Okay, this is the tangent of the inverse cosine of W. Okay, so let's talk about this right here. That must be some angle. So I'm going to call that angle theta. Okay, but you can call that anything you want. Theta is equal to the inverse cosine of W. Is everyone with me on that? So I'm just going to say that's what that is. Now, if I want to move the cosine to the other side, inverse functions, if you move them to the other side, they lose their inverse. That's another way of saying that the cosine of theta equals W. Does everyone understand? If I move the inverse to the other side, I'm basically switching the x's and y's, and that's what inverse functions do. So that inverse, I'm undoing the inverse. I'm moving the cosine to the other side. Okay. Any questions on that? Now I'm going to do something else. I'm going to write this as W over 1. Does everyone understand that W is the same as W over 1? If I take your age and divide it by 1, it's still your age, right? So why am I making it a fraction? Do you remember, SOHCAHTOA? Okay. So this is cosine, right? So which one am I going to use? So, ka, or toa? Which one has the cosine in it? Anyone? Moment? Which one am I going to use? So, ka, or toa?
Ka.
Ka, right. So if that's ka, then W must be equal to what? What's the A mean? That's the adjacent. And what does the H mean?
Hypotenuse.
Hypotenuse, right? So let me draw this triangle. And here's the angle theta. I'll put it right there. So the adjacent and the hypotenuse, which one is the hypotenuse? Which one is the hypotenuse? A, B, or C? Which one's the hypotenuse? A, B, or C?
C.
C is the hypotenuse. Thank you, Moment. Well, as long as I have, you might as well tell me which one is the adjacent, A or B. Adjacent has to be next to theta, but not the hypotenuse, so it's got to be A. So what's that going to be? That's just W. Okay. Now I need to know what B is. What is B? Okay. So here's what I'd say. This is a right triangle, so you can use the Pythagorean theorem. You can say B squared plus W squared equals 1 squared. Or you could say B squared is equal to 1 squared minus W squared. Or you can say B equals the square root of 1 minus W squared. Okay, so now I know what B is. It's the square root of 1 minus W squared. Are you okay with that? So I haven't done it. So first, I just called that theta. Then I used SOHCAHTOA to identify the adjacent and the hypotenuse. So I drew a little triangle with the adjacent and the hypotenuse. And then I found the remaining side. So now I have all of them. I have the opposite, hypotenuse, and tangent. Now, go back to the original problem. Loop. I put theta into the inside. So this is the tangent of theta. Tangent is what? TOA. So what is the opposite? And what is the adjacent? So what's the opposite here? Which is the opposite? A, B, or C? Opposite of theta. There's theta. It's there. We said it was there. I mean, that's what it is. What's opposite of theta?
B.
What's that? B. Thank you, Alexis. So B is what? The square root
D.
of, yep. Thank you. It's 1 minus W squared. What's the adjacent? What's adjacent, not the hypotenuse? It's what here?
W.
Thank you, Dennis. It's that. So the answer is going to be all of this. Soup. Okay. So it's going to be that. All right. this is the process that you have to use to get these. You replace the inside with this theta, and then you move the inverse over, and then you create this triangle and find the missing part so that you can do the whatever it says tangent or whatever you can do. So again, so here, so I picked another one. But I'm just gonna pick a different color. I'll do green. Okay, so now I'm gonna let theta equal the inverse tangent of V. So then I'm gonna move it over. So I'll say the tangent of theta equals V over 1. Okay. Then I go to the triangle and I put theta in here. And tangent is opposite. So this would be V over adjacent, which is 1. So now you can use the Pythagorean theorem and you can say 1 squared plus V squared equals C squared. That side. So it's basically 1 plus V squared. Okay, now you have to come back here and you're looking for the cosine of that. Cosine of theta. Cosine is ka, which is adjacent over hypotenuse. So the adjacent here is the number 1, and the hypotenuse is 1 plus V squared. Okay, that's how you do these problems. So let me there's the answer. Uh-oh. Where did I screw up? Tangent is opposite. Oh, I forgot to take the square root. It's 1 squared plus, it's the square root of 1 squared plus V squared. Oh. Sorry about that. I don't understand when I got to the Pythagorean theorem. I said 1 squared plus V squared equals C squared. So 1 plus V squared equals C squared. So if I want C, I have to take the square root of it. So it has to be the square root of that. Okay. All right, listen. I'm not expecting you all do great on this one, and I'm not really actually thrilled about putting it on the test, but this is a Calc 2 question. It does come up in Calc 2. It might come up in Calc 1, maybe never. But it's the last one here. The other ones were so easy. Spend a little extra time on the first and the last of this set. The rest of them should be pretty easy. Okay. All right. So I went over this quiz, but basically this quiz is all about inverse trig functions. I think that's what we're supposed to talk about today. All right. So remember, before we go, I need answers to these questions. Some of them. What is math?
The language.
Thank you, Joseph. You may go. What is precalculus?
The study of functions.
It's the language.
Octavio, it's a study of functions. What are the 4 ways to represent functions?
Right.
Alexis, graphs. What else? Graphs, data.
Table.
Words.
What? I need all 4 of them.
Words.
What are you saying?
Like words, graphs,
Words, graphs.
tables,
That's data.
data, and like equations.
That's it. Data, graphs, equations, words. Okay, what's the input called for function? And what's the output called? We were just talking about it with those functions. We had to look at the x values and the y values. What are they called? The something and the something.
Y equals and X equals.
Yeah, but that's how we find them out. One of them begins with D and rhymes with pain.
Domain and range.
That's it. Thank you, Alexis. Domain and range. Okay. If you plug a number in, like we did in the project today, what's that called when we plug numbers in? Remember I said we're only going to do half of the project today. We were going to do the what's that called? Because with an E,
Evaluate.
thank you, Genesis, you're evaluating. And what's the other one called when you want to find out a value when you solve? Oh, never mind. I told you to solve for X. Okay. We've done polynomials. We've done fundamental theorem of algebra, which is that had to do with the number of zeros. We did rational functions with the vertical asymptotes and horizontal asymptotes. We know that exponential functions have horizontal asymptote, and we know that logarithmic functions have vertical asymptotes. And now, which functions have a period? What are those functions called? We're just doing them now. Functions that have a period that repeat over and over again because they come from the unit circle. What are those functions called? Begins with a T. Anyone? I'm trying to think of a word that it rhymes with. That's a hard word to rhyme with, but it's a long word. This function has a period. What's the general group of these functions called? Does anyone remember? It's this subject. The whole topic is called this. Look how fun these are. These are all something functions. What are they called?
Trig.
Trig functions. Yep. And they all repeat over and over again, so they have a period. Okay. And we can figure out the domain and range from them. That's what that's what we're doing today. But we can also graph them. We can stretch them, shrink them, move them, and play with them the way we want. But they also have inverse functions. So the inverse functions are raised to the -1. So that's what the inverse sine looks like. And the inverse sine looks like that, but let me just show you why it looks like that. Remember when we had y equals sine of x? To get the inverse, y equals sine of x. To get the inverse, you have to switch the x's, the y's, x equals sine of y. That's really what the sine looks like when you make an inverse of it, but you can't use all of it. You can only use that piece. Otherwise, it's not a function. This will fail the vertical line test. So they just take a little piece of it. And that's why the answers come out to be weird. So when you have like the sine of the inverse sine, instead of them canceling each other out, you get weird answers. And that's why it's best just to let Desmos do them. So the y equals cosine x. Okay, looks like that. If you switch the y's and the x's, x and y, you get that function, but the only piece that they keep when they do the cosine, inverse cosine, is that piece right there. So this may be switching the x and y's, but this is the only thing that they keep from it in order to keep it have an inverse. Okay. Well, inverse tangent is interesting because if you had x equals tangent of y, that would look like that. So the inverse tangent is just one of those. It's that one. Okay, so the rest don't do. This function here is interesting because it has two horizontal asymptotes. Y equals pi over 2. And it has another one, y equals minus pi over 2. So we haven't seen that before where they had two different horizontal asymptotes. Okay. All right. I don't know about inverse cosecant or any of those, but I'm sure they have. You could just get Desmos to do them for you. So anyway, inverse functions is the topic here for this particular section. And I suppose one of the things you have to remember is if you have y equals the inverse tangent of x. Oh, I wanted that. If I have something like y equals the inverse tangent of x. Okay. Oh, I'm so over. Hold on, let me just finish this thought. Y equals the inverse tangent. That's the same as saying the tangent of y equals x. See how you get the same graph? Oh, except you get a whole bunch of other answers. So you have to remember that we only want some answers when we switch them back. But you can do it, but you have to be careful. And that's the reason why I do all those things in Desmos when I want the sign of the inverse sign. Remember, if you compose a function with its inverse of 10 pi, 10 pi pi over the 3, 4. The sign of the inverse sign of 10 pi. Oh, I know why. Let's do it this way. You can't do any of those. It's this way that gives you the problem. The inverse sign of the sine, 10 pi over 4. Those should cancel out and give you 10 pi over 4, but they don't. They give you, that, which is not 10 pi over 4. If I divide it by pi, it's just a half a pi. Okay, so let me just take this out. So that equals pi over 2. Those are the same, but they're not 10 pi over 4. And the reason why that is because of this whole trickery thing with the sign, with the inverse sign being restricted and getting rid of, instead of having all those answers, it just has one answer. So it can't give you 10 pi over 4 because that's too big. It's only going to give you answers between negative pi. Inverse sign can only give you answers between, it can only give you answers between here in this, can go from minus, I could go from minus, whatever it is, minus pi over 2 to pi over 2. It can't leave that. You can't get any other answer but those. Okay. Tangent, get anything you want. The inverse tangent of tangent, I think that's not a problem. But let's see. Yeah, so even the inverse tangent of tangent only gives you pi over 2. Okay. So you're not putting in pi over 2. If you put in pi over 2, you would get pi over 2. But if you put in more, you get something else. Okay, that's all. I've rambled over. Have a good day. I'll see you next week. Bye, Dennis. Goodbye, Alexis. I already took attendance, so you're all free to go.
Hey, Professor.
Yes,
I
Genesis.
had one question. So I had missed last class, and I had seen that there was a discussion due for the proposal. However, going into the lessons, I didn't see it was uploaded.
It's not, it should be there. Am I still sharing screen? Yes?
No.
I'm not sharing screen. I stopped sharing screen? What's wrong with me? Okay, so let's see what I got going on here. Alex, I don't need to do. So this is here. So you're in this class under lessons, and you went into discussions,
Yes.
and there wasn't a thing that said proposal?
No.
Oh, I don't see one. All right, well then let's just make one and then everyone will have to do it. I asked people in class what they were doing, but I didn't leave a spot for it, so I'm just going to do that. Thank you for pointing that out to me.
And then for that project, because I was watching the video, so once we do that, when will it be due?
When what?
When will the project be due?
Okay, so hold on. Oh, look at that. It doesn't say. Usually it's due, I see you have a practice test 2. You actually have test 2. Okay, which is due Friday at midnight on the 12th. So it's probably due around then because the final exam is due. No, no way. Wednesday is due by Wednesday midnight. I don't know. These dates are messed up. The final exam is hold on. Nobody said anything about them being messed up. All right, let me go to Mercer. Let's go to academic calendar. And we will see the last day of class is the 11th. Okay, so the reason why, that's important because the last day of class is the 11th. And that's when our final exam is. Probably not. But finals are only from the 12th to the 16th, so it's not going to be until then. I would guess. So let's just say this because clearly it's not done right. Everything will be due on the 11th. That's the last class because I want to go over. I will want to see your project results on the 11th because you're going to create a video and you're going to post that video and then I'm going to play it to the class. It's got to be less than 5 minutes long or I won't play it. So it'll be a short video and I'll play it. And then, so everyone will get to see that on the 11th. So I would say that's when it's due, on the 11th. And then the finals next day.
Okay.
Or maybe I'll give you more time. Depends on how we're doing by then. But the finals, I can't extend the finals too long. But it says the final is, when did it say the final was? On the 12th, that's the next day. So that's clearly stated here that the final and test 2 are due on the 12th. It just says it's due by Friday midnight when not, the 12th is neither of those days. The 12th is a Thursday. So that should say Thursday. Both of those should say Thursday. So let's just fix that because I'm not always good with the days of the week. So this is Thursday at midnight. And this is also Thursday. Well, that averages up. Okay, the test 2 is just a knowledge check. The final is the final, you answer questions, but that test 2 is just another knowledge check at the end. Okay, and the practice final is due on the 11th. Practice test 2 is due on the 11th.
Okay.
You need practice test 2, and I don't think that's what we're going to eliminate. I think we're going to call this the project. Is due then on the 11th because that's the last day I could make it due. I can move it up, but that's when it is. All right. Okay.
All right.
Does that answer your question? Does that seem reasonable that we can do let's see. It doesn't, practice tests just count under quizzes. So they're just thrown in with the quizzes. So if there's a practice test 2, it's just thrown in as a quiz, but yeah, it should say that somewhere else. All right. Thank you, Genesis, for pointing that out.
All right. Thank you. Have a good evening.
You too. Bye-bye. Joseph, did you have a question?
No, sir, I'm good. Thank you.
Okay. Have a good night.
You too. Thank you. Bye.
Bye-bye.